Hello everybody, and welcome to our webinar. Really quick introduction so you know who I am, so you've got some context. So my name's Francis Norman. I'm the CEO for Centre of Decommissioning Australia, based in Perth, Australia. And very excited today to be sitting down with Petter from Control Cutter to talk about their unique pin and cut technology. You might have picked up from the registration page, but to those who haven't, and just for those watching this video afterward as well, of course, Petter is the executive director for Control Cutter. He has over 25 years of experience in the industry, working both offshore and onshore, with the last 15 years spent in management roles. Prior to joining Control Cutter, Petter worked as managing director JP Kenny in Norway and Russia, and has also spent time at Wood Group and at Weatherford. So a man with a lot of experience and some really good insights to share with us. So without further ado, Petter, I'll hand over to you to give us your share all your wonderful information about the technology you've developed, please.
Appreciate that, Francis. Good morning or afternoon, wherever you are in the world. I'll get my presentation up and running here. Hopefully, should be working all right. So, can you confirm that you see the screen, Francis?
Yes, I can see the screen, Petter. That's good.
Excellent. Well, I'll just crack on then. I'll start out with a bit of a background of Control Cutter. It was founded back in 2010 by myself. And the reason that I did start this company was because of an accident of an anchor handling vessel in Norway that capsized and sunk, and 8 people were killed because they couldn't get rid of their mooring line. So I set out on a journey between 210 and 214 with the aim to try and cut a mooring chain of 84 millimeter. Was sort of the goal that we set out to do this in 10 seconds, and in 14 we were able to showcase this technology, and we were able to cut an 84 millimeter chain in less than 1 second. And when I was supposed to get rich and famous in 2014, I did not, because, as you all know, that in 2014 the anchor handling business just plummeted, and we sort of had to look for elsewhere to utilize the same technology. So luckily for us, we were able to go in with a project with Exxon, and using the same technology that we were supposed to use on an anchor handling vessel. We took the technology subsea, where we were launching a project up in St. John's, Canada, cutting loose 622 millimeter chains, and releasing a platform for Exxon. What's unique with this technology is that we developed a very special cylinder system that means that we can cut many times very hard material without actually damaging the cylinder system. And also the blade technology that I'm gonna sort of showcase for you is also something that we developed, meaning that we can cut a lot of that being chain or conductors many times without actually damaging the blades. So in 2017, we started on the topic that I'm going to talk to you about today, which is cutting large conductors and also pinning the conductors and inner casings. So conventional way of doing this is that you use a bandsaw to sort of cut through the conductors and inner casing, and you're using what you see on the left here that says a Mirage, which is a DDU. So it's basically a hole saw. So you drill in from 2 sides and you drill a hole, and then you stick a pin in to sort of secure the inner casings. We do the same thing, only different is that we do not drill holes. We actually push a pin straight through with a special arrowhead, which has the same setup as the blades that we're using to cut. And as you can see, if you have a 30-inch by 20-inch by 13 3/8 and 9 5/8 fully cemented, that could take up to 3.5 hours with the conventional technology. We will do this in less than 10 minutes. And as you can see on the bottom here, this is a project for Conoco in Norway, a 23 well project. where the conventional technology would have taken them 40 days, and we carried out this in 46 hours. So you can see there's a lot of time to save on this part of the decommissioning phase 3 when you're doing P&A. So let me then talk a bit before I go into a couple of projects that I wanna show you. For us, it doesn't really matter what type of setup you choose when you're doing a phase 3 or decommissioning. We can either do this from a hydraulic workover, as you can see to the left there. We can do it from a drill floor. We could do it rigless, and we can even do it with a heavy lift vessel. We've done project with all these 4 setups, and I will showcase 2 of them. So what's different between the conventional and ours? First of all, time, I mentioned that to you, but also the personnel side, we do take that down a fair bit. So we only had run this setup with 1 to 2 guys per shift. The system is fully automated, meaning we just install it once, and then we can skid back and forth to the conductors that's to be pinned and cut. And I can even run the tools from my office if I want to. Conventionally, you will see that you have to use a tugger or a crane to crane in both tools onto the conductors and off again very often, meaning you have a lot of high risk red zone lifting operations. As we have an automated system, you won't see that, of course. So that sort of improves the HSE as well. And thirdly, the way we commercially run this is that we have a standby rate on our tool, and then we run with a pay for performance, meaning we take a premium for each cut and pin we do. We do not mind doing this performance paid setup, because we know that we will be able to carry out the cutting and pinning, which I will showcase for you now in the next few slides. So let me start here with this is a operation being carried on a platform jack-up on a drill floor. What's special about this one is that it's not a 1-inch conductor, it's 1.5-inch conductor, so it's quite thick, and you have 2 inner strings here, 13 and 3/8 and 9 and 5/8, partially cemented. On this picture, you can see that we have the pinning tool, which we call the Decom dart, on the lower side, and then on the top side here, we do have the cutter itself. So just starting the movie here now, and you can see how this works. You see the conductors coming up, the pinning tool goes in, you carry out the pin, and then you cut, and you remove the cutout section. Then you put on the bales, carry on, lifting up the conductor again, in, carry out the pin, and doing the cut, and you go on this way all the time. I rerun it so you can see it again. And as you can see, there's never any people involved in the pinning or cutting operation. You have a clean drill floor, so there is no people exposed to anything when we're doing the pinning and cutting. So for this particular project, this was a 9-well project, and as you can see here on the left side, we did save the client 133 hours, and this case study here is approved by DNO, which is the operator, and Well Safe Solutions. These are their numbers, not mine. And as you can see, 133 hours saved on this 9-well project. What you can also see is that the CO2 was taken down by 93%, which is something that the operators are really keen to see, that we can reduce the CO2 emissions. But by far, if you then look on the lower case there, you can see that we avoided 209 red zone lifting operation using our technology. And then you're back to what I spoke to you on the previous slide, where you have the conventional tooling have to be lifted in with a tugger and out again, which can potentially cause crush injuries and others damage to personnel and equipment, of course. Then moving on to a rigless setup. When I say rigless, what I mean by that is that you no longer having a drill floor. You're actually just on the wellhead. And what you see here is that you have a frame where we have the upper tool that do the cutting, and you have the lower decom dart below here. And this frame, you see there are some yellow lifting points. So what we have here is that on the side here, you will see soon in the movie, you have a jack up with a big crane. That's the only thing which is on this jack up. And basically, the crane is used to lift up the conductor. We then deliver a false RKB, a rotary Kelly board with the bushing and slips and everything. And when you've done one conductor, you just pick up the full frame and then you lift it to the next slot. So it becomes a really efficient way to remove the conductors if you have a heavy lift barge with a heavy lift crane on board. Running the movie for you, so I'm just gonna briefly stop it to sort of give you an idea when we get the picture up here. So you can see here, here is the jack up. It's called the ALDA. You're laying down the conductors over on the jack up itself. We have a lay down basket here, and then you have the full frame with the tool. And here you have the lifting arrangements that we use to lift the whole frame from slot to slot. So next we will move to this slot, of course. So you can see then I restarted so you can see it again. So you see the conductor is coming up. Then we run in the decom dart to put in the next lift pin. And then carry out the cut, just as the previous movie showed. And then the conductor is being put on a duffel bag just to prevent any sort of cement that could fall out when they're putting it down, and then being laid down on the barge. Again, this was a really small project, very shallow water project, but we did still manage to save 56 hours on this 4-well project for the client. And we did reduce the emissions by 96% on this project, and a total of 91 red zone handlings avoided. Up on the left there, you can see the laydown basket that I mentioned for you, so which is really efficient and really good way to control everything in a safe manner. So you just lay it down and then you lift the whole system again, the whole cutout conductor to the side, and then you just carry on. Third project that I'm going to showcase you is for Chevron, called the Mary B, that we carried out down in Israel. This was only an 8-well project, but it was really deep, 275 meters, and 480 pins and cuts was carried out. In this project, we saved the client 26 days, according to Chevron themselves. And the whole project was done in what we called then a workover basket, a hydraulic workover unit that we were positioned up here in the top side. So here you can see when we're running this operation, these are done with jacks. So basically the system is, the conductor is being jacked up by hydraulic jacks, and there's a crane above us that lifts out only the cutout section, because the crane had limitation itself. That's why they're using the jacks. So here the pin is going through, pin is done. You open up the decom dart and you stick in a lifting pin. And then the cutter comes in and carry out the cut. And then the upper section is now attached to the crane and is just being lifted out by the crane. So these are the projects that we have carried out so far. And as you can see here from the track record, we have built a fair amount of project that we have now carried out, and that is continuing. Not on this list, our project like we just carried out recently was for E&I, where we did a 10-well project in the UK, amongst others. And as we speak, we are now just started on a major project for Chevron over in California, where we're going to be doing 29 conductors. Again, a very deep project with one conductor and 3 inner strings. And there's about 25 cuts per well. And estimate is that they can actually shut down this project 70 days ahead of what was planned because of the cutting and pinning that we carry out. So what is the value drivers here for the operator? Well, first of all, wells down demand schedule is of course where the operator saves the money. But as I mentioned for you, it's the safety element. I mean, less people required in general, but also as you have less of a lifting operation, you do improve the overall HSE on the project. Also, as I mentioned, the POP constraints is also an issue on these projects, so therefore reducing the POP is always important. And of course, deck space is always an issue. We only bring those 2 tools with us and an HPU, that's it. So it doesn't take up much space at all to run these operations with our tooling. So just to sort of sum up here for you guys, what is the value drivers here? Of course, here on the left, you can see the conventional cutting and pinning in gray. So yeah, less people offshore is a cost saver, increased efficiency on both these pinning and cutting. But by far, of course, it's the OPEX that is really the time saving for the client here. That sort of gives you the blue part here on the right side. That is the real cost that's being reduced. And if you were to give this a number, we are in a range of about 15 times more efficient than you would do with a conventional type of cutting and pinning. So that sort of concludes my presentation, and I'm happy if you have any questions.
Oh, that's been super. Thank you very much, Peter. We've had a couple of questions come into the chat already, so I'll move straight into those now. So we've been asked here if you could clarify the purpose of the pin. Is it just for lifting the conductor, or is it designed to secure the inner strings inside the conductor in case the cement's not sufficient to hold the inner strings? Also, how does the pinning system work?
So basically what we do with the pinning is that you push a pin straight through all the conductor and the casing itself. In front of the pin, there is what we call an arrowhead that we then unscrew on the other side when the pin is through. And the purpose of the pin is there are 2 things to that. First of all, yes, correct. It is to secure the inner strings to the conductor to prevent it from falling down, because you never really know whether you have a good or bad cement job. So either way, you need to secure the inner pin. And secondly, of course, you're using that pin to also lift the whole section when you're lifting out the conductor.
Oh, that's great. Thank you. So the pin itself, then, it's just hydraulically driven. Is that right? It's essentially it's forced through with hydraulics.
Yeah, so it's hydraulic driven, and you just use blunt force basically to push it through. That's what you do. Yeah, that's correct.
Yep, that's great. Excellent. Thank you. So another question we've got here now is, what's the largest diameter the tool can pin and cut, or what's the biggest, I guess, combination of diameter plus conductor?
Yeah, so today we done the biggest tools we have today is 30-inch. So we can do 30-inch with 4 and 5 inner casing. It's not a problem for us. Fully cemented. Going higher than 30 inch is not a problem. It's just a matter of scaling up the tool. But the reason that we ended up on 30-inch is that by far that is cover most of the projects that are out there. We do see from time to time maybe 36, and we are in the process now for um, building a 36-inch, meaning actually a 40-inch, because the tools that we have do not only work topside, we're also doing subsea project with them now. So in Q1 24, we're actually doing on Brent Charlie together with Allseas, we're going to do pinning and cutting of conductor actually subsea. So the tools can also be operated subsea through the a work ROV, so you don't need any umbilical or anything to the surface.
Well, that'll be a beast of a machine when you get that next size one finished on it. It'll be enormous. That's excellent. So another question just popped in. Have you thought about using it in a horizontal configuration to recover pipelines, such as where there's old concrete weight coating to crack off, pipe can't be held reasonably?
Yeah, so we're already doing that on a smaller scale. So we have a lot of subsea tooling as well. I didn't touch upon that here today, but we've been all the way down to 1,500 meter water depth, cutting pipelines, flow lines, umbilicals. So the system is already approved to go subsea and working through the work ROV, as I mentioned. So that's something we can do. Larger pipeline, that is why we're looking into the 40-inch tooling, is actually for that purpose, is to cut pipelines subsea.
That's good. So it sounds like we might be up for a second webinar at some point in the not too distant future on that lot then.
Yeah, sure.
No, that's good. So I'll switch back across. I have a couple of pre-prepared questions of my own as well. So how often do you have to change the blade? What's the sort of life expectancy between changes?
So if you look at the conventional bandsaw and hole saw, you would probably maybe get 3 or 4, maybe 5 cuts out of them before you have to change them. On the Mary B project that we recently did, we did not have any damaged blades before we had done about 120 cuts. And it's just a small part, so the blades are segmented, so means that it's only a part of the blade that we change out, and it takes us less than 5 minutes. So when you're lifting out the conductor, we can replace that blade if it's been damaged. So the wear and tear both for the dart and for the cutter is really small.
That's incredible. That's great. And then one more question, and you touched briefly on this in your presentation, but it just maybe if you could dwell a little bit more on it. The commercial model that you talked about, the charging on a performance basis. Could you talk a little more through that as well, please?
Yeah. So where the client's saving time here is, of course, because we cut a lot faster. So basically, our commercial structure is that the tools are there, they're a standby, but every time we carry out a pin or a cut, we take a premium for that. So we go in and say, yeah, we will cut this in 5 minutes. We don't have a problem by saying so. And if we perform the cut or the pin, then we charge for that. And what that means is that firstly, you have a standby rate on the tools at all time, which the clients then can cost. And of course, they're only paying when the tools are operating the premium for the pin and cut. So it's sort of a win-win position for both the client and ourselves. And we've done this on all our projects, and all the clients that we're working with are really happy with that structure.
It's good to see different I guess, different costing models and different ways of approaching these. Look, that's I've got to say that's been absolutely fascinating. I've we had a quick chat about this when you and I first met, but to have the proper talk through on this has been absolutely brilliant. Um, we don't have any more questions in the screen at the moment, so maybe I'll ask sort of one more question, and then we can wind things down. If people want to know more about this, what's the best way to get hold of you?
Uh, uh, Feel free to go in on our webpage, controlcutter.com. You will find my name and email on that page. And please feel free to contact me, whether that is topside for taking out conductors, or if you have any inquiries related to subsea work as well. And I'll be more than happy to showcase subsea projects that we also have done in the past. Yeah.
Absolutely wonderful. Look, thank you so much for this, Petter. It's been fascinating, and yeah, look, it's been an early morning, I guess, for you to come on and talk to the rest of us around this. Look, enjoy the rest of your day, and to everybody that's joined the call, watch out for the next ones of these as they come forwards. We've got quite a queue now of people wanting to do similar webinars to this. So I'm very much looking forward to us starting to host a few more of these out into the near future. And yes, look, thank you very much. And we'll speak to you next time.
Thank you so much. Have a good weekend all. Bye bye.